the lunch.
Is this okay? Yeah. No, it's okay.
So now it's time for Kenneth. He's coming from University of Gent, and he's one of the main developers and of EasyBuild, which is now 5 years old project. And most of you have already large exposure to that thing. I have seen a lot of contributors in the Zoom from EasyBuild. It's good to have you here. Thank you so much.
Okay, thank you, Jordi. All right, let me get started with what my boss has asked me to do. Maybe before we get started, who knew about EasyBuild before coming to this meeting? Okay, that's good. Who's using it? Or who has used it before? Who's using it in production? Good, okay. Todd, ask the same question when you start. Sorry. Okay. So first of all, let me briefly introduce Gent University. We're part of the central IT department, so the HPC team is at the central IT department, which means we cater to the whole university, so across all scientific domains. All the researchers at Gent, also industry in Flanders, and even beyond that, we help them out with everything that they need. And we're a member of the Flemish Supercomputer Center, just like Ingrid and Jorik are. So we also collaborate in Flanders on everything HPC. For myself, my degree is in computer science, also from Gent University, which is very boring. I've been there for 17 years now. I joined the team in 2010, almost immediately after finishing my PhD. I was a user of the first systems they had. They were looking for a guy to help out with user support, and I figured I was a user, so maybe I can help out with that, and it has worked out really well. So today, user support is my main task. I'm like the main responsible person in our team for that. We also do user training and a lot of software installations, which is, of course, what this is about today. EasyBuild was pushed into my lab quite quickly after starting in the team, because the guy that started it, he's our tech lead, and he didn't really have time to keep it going. And then since then, I've been the lead developer, release manager, all of that. I like a lot of loud music, and then maybe you've seen my sweater, the FOSDEM sweater, so I'm a big fan of open source software. If you don't know about FOSDEM yet, Google it and come to Brussels first weekend of February every year. There's 5,000 people there. It's crazy. It's not even a conference. It's very weird. There's beer everywhere. You get in for free. You don't even register. You just walk around. Nobody knows you're there. It's a cool place. You should definitely take a look. Okay, so what is EasyBuild about? It's about getting scientific software installed for the users. Basically, all HPC sites have to worry about this, and it's a big issue, or at least it was a big issue. Ideally, you want to build from source because you want to get high-performant installations. It's a lot of work to install scientific software, especially if you have to cater across all scientific domains. I mean, in Gent, we have over 1,000 applications installed. That's not including versions. So it's big. It's huge. And you quickly realize, like Steen did when he started out EasyBuild, if you don't automate this, if you don't have a good way of dealing with this, you're just going to be installing software, and that's going to be the only thing you do. It's a huge burden. I think about a quarter of the support tickets we get is asking for either new packages or package updates or maybe problems with existing installations, but it consumes way more than a quarter of our time. So we want to be very efficient with that, and we want to collaborate with other people who are suffering from the same problem. Okay, so what's the actual problem with scientific software? Well, it's created by scientists. They're not software developers. They care about the science behind the software. They want to get science done. They don't really like probably even doing software development. So they're not following the best practices, so you end up with, let's say, interesting installation procedures. They use build tools that are maybe from the 90s or the latest best thing because they saw it at a conference. I consider CMake a broken build tool, by the way, because be on the point. Sometimes it's very incomplete. They just say, oh, just do make and everything will work. You don't get a clean installation. You can't really configure it right. If you want to build with Intel compilers, you have to dive into the make file, change the compiler options. But yeah, there's a whole mess. Some people like interactive installation scripts, which is you want to just get the build done and you don't want to have the thing ask questions to you because you have to figure it out all the time. Hard coding, documentation is a big issue, especially the installation part, and so on and so on. So a good example of this is WRF, WRF. It's a weather modeling software. I'm sure some people here know it. It has a bit of a reputation. It has a bunch of dependencies, nothing too difficult, and it's not a whole lot. It's about a dozen dependencies. They're pretty standard. Maybe the biggest issue is netcdf, which got split into separate C, C++ Fortran things, and WRF just assumes everything is installed in one location, so you have to, if you're not doing that, you have to make it aware. If they find bugs in WRF, they don't do a bug fix release. They have a website where they report the bug and they say, okay, change this line in this code file to this new line and recompile, everything will work. The patch file is non-existent, not even a bug fix release. So these people do not do software development. They do the science. And I hope they get that part right. So if you unpack the WRF tarball, there's a configure script, and you say, okay, yes, I know this, configure, prefix, yada, yada. No, it's an interactive script that it actually calls a Perl script that starts asking you questions. The fun part is, so one of the questions it asks you, do you want to use GCC, do you want to use Intel compilers, PGI, yada, yada. Just for kicks, they change the order of the options between versions, so you can't like hard code a number because you're suddenly going to be using PGI, which is probably not going to be there, and so on. The configure script generates a configuration file, and it tells you, please check the configuration file, and you have to go in and change it because it doesn't get things 100% right or not entirely like you want it to. Their compile script is basically a wrapper around make. It has an option to build in parallel. If you try it, it doesn't work because their make file is broken. You have to fix the make file first. And there's no installation step. Just after make, binaries are there somewhere, not in bin. That would make sense, so they don't do that. They're like spread out all over the place. You actually have to run make 3 times to get everything that you really need. It's a mess. Yeah, so software installation is not a new problem, right? It's been there as long as Unix has been. And there's tons of package managers and stuff like Homebrew. Package Source is a very old and very big project. It has 10,000 different software packages that they support. There's Portage in Gent 2. More recently, there's Nix and Geeks, which are functional package managers, whatever that may be. But none of these tools are really well suited to scientific software or HPC systems. They don't really care about having multiple versions installed side by side. They don't really care about anything else than GCC. MPI, they have no clue what MPI is, and so on. So it's not really a good fit to this problem. So back in 2009, shortly after our team got started, because we're quite young, Steen, who was the main technical guy back then, quickly realized this is just going to explode in my face. If we have to work for the whole university, this is never going to work. We will never get enough manpower to cater to everybody, so we have to figure out a good solution. He started looking around. His first attempt was writing spec files for scientific software to generate RPMs for that. And after doing that for 2 or 3 packages, he says, okay, this is never going to work out. He got frustrated enough that over summer, during his holidays, he actually started the project from scratch, which ended up being EasyBuild. So he picked Python as an implementation language, which he kind of knew, and it started like this. So we're still doing the lead development today. After a bit of internal development, we released it under the GPL. And today it has well over 1,000 different software packages, together with a bunch of Python library and so on, R, Perl. There's a whole community that has emerged around it, which kind of surprised us. It happened. It's well documented, website, yada, yada. So this year actually marks the 5th year of having EasyBuild available publicly. It's been developed for longer, since summer 2009, basically. That's when it got started. So it's actually 8 years. But we only open sourced it in 2012 after it got cleaned up a couple of times by interns we had. because we weren't very good at doing software development either ourselves. So it took us a while to clean it up and be confident enough that people wouldn't laugh in our faces when we pushed it out there. Our first idea was we wanted to get feedback on it. We were somewhat expecting that people told us, what are you guys doing? This problem has been solved 20 years ago and you're not using this tool. Why are you reinventing the wheel? That didn't happen. Actually, people quickly after we realized it, people started Googling for it because they had a new HPC cluster and they had to go through all of the software installations again. We started looking around. We had a paper at the HEPEX conference, a paper at Supercomputing 2012 where we actually did the release the night before having a talk, so that was interesting. So people started finding it and then the community emerged around it rather quickly. So first in Europe and then wider, which was a bit surprising and it kind of like exploded in our face. We were never expected this to happen. Since the 1.0 release, we've had lots of stable releases. About every 6 weeks, 8 weeks, we have a new release with a bunch of new stuff in it. Certainly new software, also features in the EasyBuild command line, in the framework, and so on. The development is driven by the community. We get bug reports, of course we do. So we try to react to these, to the bug reports, we get feature requests, we get a lot of contributions as well. Certainly the last, let's say, 1 or 2 years, people are not just complaining that something doesn't work, they're actually fixing the problem for us and submitting a pull request for it. So that's definitely good. We're starting to get a lot of return from the efforts we did. Supported software in the latest releases. So it's actually 2 things because I want to make sure we can make a good comparison with Spec when Todd starts to talk. We have over 1,200 software packages. And I'm not counting stuff like Python packages, R libraries, Perl modules in here. So that's like another 1,000 that we have out of the box. So it's well over 2,000 tools, applications, libraries, if you want to count like this. We support a bunch of compilers. So EasyBuild has a whole bunch of logic to deal with different compilers, deal with different MPI libraries. So it knows how to compile, it knows how to put these runtimes in your environment, and so on. Same for BLAST, LAPAC, F50W. We have pretty good support on Cray systems now, so we worked on this together with the people at CSCS in Switzerland. So Pitts Daint, which is one of the, I think, still in the top 10, in the top 500. They're also installing software there with EasyBuild, so we must be doing something right. I wanted to show you. So there's a lot of the slides have links on them, and we have a page here that's basically generated, so it has an up-to-date list of all the software we support. We tried to do a good job of organizing it. It also mentioned versions and which tool chains that have out-of-the-box support for this software. So definitely take a look there. Try to find the package that you have to spend most time on and see if EasyBuild supports it, because that's a good use case to try and play around with EasyBuild. It will quickly convince you that it's a good thing to start using as well. Some terminology before I continue, because I'll start dropping some of these terms. So the EasyBuild framework is basically the heart of EasyBuild. It's a bunch of Python modules that support functionality that you often need when installing scientific software or installing software in general. It goes from simple stuff like unpacking tarballs, applying patch files, running shell commands, and collecting the output, checking the exit code. All these kinds of things are supported in the framework. Also, there's a kind of library in there that generates module files, so all of that is taken care of in the framework. Then we have a bunch of easy blocks that basically are plugins to this framework. And each easy block, it's basically a Python script that implements a build procedure. So for example, we have an easy block for configure, make install, which is a generic easy block. We have a separate easy block for WRF, which is the weather modeling thing. Because it's so non-standard, we need a separate script for that. Then next to this, we have easy config files, and I'll show one of them for WRF in a couple of slides. So these are basically build specifications. They're text files that have key value pairs in them that tell EasyBuild which software you want to build, which version, which compilers and API to use, what the dependencies are, the versions of the dependencies. All of that stuff is specified in an easy config file. And it also specifies which easy block to use, which then hooks into the framework to actually install the software. A compiler toolchain is basically a set of compilers, for example, GCC, typically with an API next to it and a BLAS Layback library next to it. And EasyBuild knows how to leverage this toolchain. So it will prepare the build environment when installing software with a particular toolchain. And then extensions is stuff like Python packages, R libraries. These are kind of different from installing a normal or an application or a tool. So what can EasyBuild do? Well, it can fully autonomously build and install scientific software for you. Even if it's using an interactive script, configure script like Wharf has, EasyBuild knows how to extract the questions from the interactive script, and you tell it what it should answer based on the context and yada yada. So even stuff like Wharf, where the numbers change, EasyBuild can do a pattern match on the question, grab the number, and use that as an answer. So it has a lot of logic to do that. It takes care of dependencies for you. So if the software has dependencies, it knows I have to install the dependencies first in the right order before I continue to the application. It also generates module files, and you can pick whether it does Tickle or Lua syntax. So I'll mention Lmod a couple of times. We have very good support for Lmod. It logs everything it does into the very nasty details. If you dive into an EasyBuild log file, there's a lot of information there. So there's a lot of noise there as well. But everything you need to know about what EasyBuild did and how it did it and why it did it, you can figure it out later if you have to. We archive the easyconfig and the patch files if you have to reproduce an installation later. For example, if you buy a new cluster, you want to reinstall all the software you had before, everything is there to reuse. Just fire up EasyBuild, come back after the weekend, and your cluster is fully populated with software. You can configure it to your liking, of course. So basic things like where does it have to install software. Up until almost every aspect of EasyBuild you can configure. You try very hard not to hard code something. And it has 3 configuration levels. I'll get back to this later. You can extend it easily. So EasyBuild comes with a bunch of support for toolchains, compilers, API out of the box. If you're working with some proprietary API library, you can write a small Python module, Python script for it, give it to EasyBuild, and EasyBuild will pick it up when it has to. So you don't have to reinstall EasyBuild. You don't have to contribute back if you don't want to. EasyBuild can just pick it up and go. If you want to name your modules differently than what EasyBuild does, you have support for that, and I'll discuss some of that. So that includes using hierarchical modules, and I'll explain what that actually means. So Robert mostly skipped over that because he knew that I was going to explain this. Transparency of what the installation that EasyBuild would be doing, I'll show that as well. We try to be very serious about testing, so every change we make in EasyBuild triggers our unit test suite, which is now over 250 tests. So we're not aiming for 100% coverage or anything, but we get very good feedback from the tests. We're basically pretty confident that if we change something, the behavior is still backwards compatible and we don't break anything by accident. If we do a new EasyBuild release, we basically try to reinstall all the software we've supported up until that point to make sure that nothing breaks. So if an installation worked before, it should still work with a new EasyBuild release. That's kind of the point. So you want to make sure that you can reproduce installations, even very old ones. Actively developed, frequent releases I already mentioned. It has, certainly today, it's a collaboration between HPC sites worldwide, and I'll get back to the community aspect as well. Very large sites are using it, lots of small sites as well because of the manpower issue. It's a worldwide community. So to take a step back, one important thing to mention is what EasyBuild is not. So it's not a replacement for Make or CMake or any of these tools. When your software is being installed with CMake, Make, Install, that's basically what EasyBuild does, but it just wraps around all of these tools. So you still need those. It's just EasyBuild calling them rather than you doing it manually. It doesn't replace package managers like Yum and apt-get. You still need this stuff. It like builds on top of them because we try to install everything from source, compile with Intel compilers, the right API library, yada yada. Some things it still makes sense to provide it via your package manager, like InfiniBand libraries and drivers. Do that through RPMs. Don't let EasyBuild do that. There's too much tied to the kernel you're running and so on. Also, security stuff like OpenSSL. It's probably better to do that through the package manager and get updates. And it's not magic. I mean, it cannot fix all the problems for you. Sometimes an installation may not work, or you'll get compiler errors. It happens, and EasyBuild can really fix that for you. So what can it do? It's really a uniform interface to install software on HPC clusters. So you're always running EasyBuild, and you basically stop caring what's behind it. How do you install OpenFOAM? I kind of know, but all the details are certainly I forgot, because EasyBuild knows how to do it, and it does it very consistently. It's a huge time saver, mostly by automating all the repetitive tasks, like applying patch files, all this stuff. You stop worrying. Which order do you put the options in for tar, and all this stuff, you forget about it, and make silly mistakes. Takes care of all the boarding stuff for you. It's a way to install a very consistent software stack for your users, so they learn how you're naming modules, and it's always the same thing, no matter who does the installation. So whether it's John or Bart doing it, you always get the same thing. You also don't have to wait until the installation guy is back from vacation to install software. If they know how to use EasyBuild, anyone can really do it. And it does the right thing according to the EasyBuild configuration you're using. It has become an expert system for software installation. Lots of people are putting their knowledge into the tool, like tiny details that you may have to get right to get a good performing installation. It's in there somewhere, or it may be in there somewhere if somebody added it. Yeah, again, platform for collaboration. And it also allows to let users install their own software stack in their accounts, because it's pretty straightforward to use, especially if they're just using the recipes that are included with EasyBuild. You can say, okay, if you want to have 1,000 versions of Blast and you want to experiment with it, sure. We're not going to install these centrally, but do it in your account, run this command, it will install everything for you. And it can do so on top of what you provide, so they don't have to reinstall everything themselves. This is example output of if you run EasyBuild, for example, to install GCC, which is not entirely trivial. That's all you need to do. EB, GCC version, it goes, and after, well, it takes maybe 1 or 2 hours to do it, but it should finish the job. The GCC build we're doing is a 3-stage bootstrap with a bunch of non-standard libraries like Klug and all this mess in there, which makes it tricky to do by hand. But so what happens when EasyBuild does an installation is basically it goes through this stepwise installation procedure. It reads the easyconfig files, so it knows what to install, figures out where the sources are. If it has to, it can download them for you, if there's a URL specified. It will prepare the environment by unpacking, setting up a build directory, applying any patch files. This prepare step figures out which toolchain is being used and sets up the environment, so like $CC, C flags, all of this stuff. Then it does the standard or the common configure, build, test, install cycle. So depending on the software you're using, this may not be a configure script, but something else. If there are any extensions like Python packages, it will do that after the main installation. It does a sanity check, which means it will run very simple commands like running --help or checking whether the main binary is there, just to make sure nothing really, really wrong with the installation. Because sometimes you may not be aware, sometimes if you run make, it exits with 0 even though nothing happens. So relying on exit code is not fully reliable, so EasyBuild checks and makes sure that everything, or at least the common things that are supposed to be there are really there. If it's happy, it will continue with cleaning up after itself, generating the module file, making sure the permissions are right, which can also be a problem. If you want to, you can generate RPMs from this installation and maybe run any test cases if they are available. The key thing here, this is like the generic procedure, which is done for each installation, but each of these steps can be customized if they have to. Like for Wharf here, we would run the interactive configure script, and the build step, we would run their compile script, because it does a little bit more than just make, and so on. And you can customize this either through the easyconfig file or through the easyblock. It depends on how complicated the installation procedure is. So what do easyconfig files look like? It's basically a text file that's key value. Today it's still in Python syntax, so you don't really need to know Python to write an easyconfig file, but you need to get the syntax right. Some, of course, are mandatory, which software, which version, which toolchain. Some metadata, we also enforce this, so you know at least the homepage of the software, you can get access to the documentation. Some of them are very common. Usually you have sources, not always, but usually you have sources, patch files, which dependencies, options for the commands that get executed in the steps, and the sanity check is usually specified as well. So this is an example. It's not terribly readable, probably, but you can take a look at the slides afterwards if you want to get the details. It's an easy config file for Wharf. So what we do is we specify the name and the version, the homepage, and a short description. So this metadata will go into the generated module files. If a person does module show or module whatever, they can actually see what the module is providing. We tell it to install with the Intel toolchain, so Intel compilers, MPI, MKL, a particular version of that. Which sources, which patch files to apply. So we've created a patch file for the website that they have with the bug fixes, which get applied automatically. Which dependencies to use. And one important thing here, especially compared to Spec, is that we fix all the versions. So you have to tell EasyBuild which versions of the dependencies to use, which versions of the toolchain to use, and so on. And then here, this is specific to Wharf. So this is telling it to do a distributed build. So dmpar is a keyword you give to the configure script or the make. I forgot which one. And this is kind of like a variant. So it tells this will come into the module file. The dmpar will be part of the module name that EasyBuild generates. So this gives EasyBuild all the settings, basically, all the parameters. And then this will trigger the Wharf easy block. It's not explicitly specified here, which basically tells EasyBuild, OK, for this software, there has to be an easy block that knows how to do this. So EasyBuild will hunt it down, pick it up, start running it, and feed it this information. So because it's 5 years of EasyBuild, I wanted to talk about 5 different aspects that I found important and have been developed over the years. So the configuration, which I already briefly mentioned, you can use configuration files, environment variables, and of course command line options. And these are consistent. So every option you get, you can specify on one of the levels. Everything is there all the time. And which makes sense to me. The command line overrides the environment, which overrides the configuration file, which overrides the defaults that are there. It's well documented. Everything is detailed there. And to extend EasyBuild, so you can have your own easy config files if you want to. So and typically big sites do. They want to be in full control rather than using things out of the box. You can just give them to EasyBuild. EasyBuild will pick them up when it has to. You can even add your own easy blocks, maybe for proprietary software. Again, if you have a particular compiler toolchain that you want, maybe with a vendor-specific MPI, you can tell EasyBuild how to use that and so on. Your naming scheme, you can also just include it dynamically in EasyBuild. And again, the documentation is there. So if you want to check the current configuration, there's a show config command. What it will do, it will list the most common or the most important configuration options. Where is the software going to be installed to? Where are the build directories going to go? Where it's going to look for easy config files and so on. And then any settings you customize will also appear in this list. And it will tell you on which configuration level these were set. So this was set in the configuration file. These, with the E, were set in the environment. And this is the default value, and so on. So you can get a quick idea of how EasyBuild is currently configured if you want to double check things. Integration with Lmod. So this is something that happened over the years. So the initial support for using Lmod as a modules tool was added back in 2013, and kind of because we had to, because it was so easy to install lots of modules with EasyBuild. The tickle-based modules tool was too slow to deal with that. A module avail took like 20 seconds, and users got annoyed. And we started looking for better options, and we ran into Lmod, tried it out. It was really well done, even back then already. So over 4 years ago, it had a module cache, so module avails are instant. It supports a hierarchy, so if you want to organize your module tree differently, and I'll show that, it has very good support for that. And then later on, we also added support to EasyBuild to install modules in a hierarchy rather than in a flat scheme. Lua syntax, which is important for speed in terms of loading and avail, all that stuff. And recently, since EasyBuild 3, Lmod and Lua are the settings by default. You can still change it. You can still use the tickle-based modules tool. But we really recommend people to start using Lmod if you're not already. So there's a synergy that has grown between Lmod and EasyBuild over time. So we reached out to Robert via the mailing list and started having discussions about combining EasyBuild and Lmod. We ran into some performance issues with Lmod, and some of the Lmod people ran into performance issues with EasyBuild. So there's a big back and forth there. And basically, both tools got a lot better because of the collaboration. So that was interesting. I wrote the update cache script that maybe you're using for Lmod as well. I have a couple of papers together with Robert, and over time, we basically became friends. So that's a nice side effect. So in terms of modules that you can use, this is not really specific to EasyBuild, but EasyBuild can do all this for you. So the standard way of organizing your modules is what we call a flat scheme. So basically, everything is available all the time. All the modules are there for loading straight away, which may mean your module names become very long, very confusing for users. So they can't really figure out which FFTW they should load here. They don't really know so these are Toolchains in EasyBuild. They don't really know which one is better or more recent. It's not very clear to them. So it's a bit of a mess. So the blue means you can load the modules directly. Green means they are loaded, so they're non-loaded here. If you compare this with a hierarchical scheme, this is basically what happens in a hierarchical scheme. When a user logs in and they do module avail, they only see a handful of modules. And typically, this is organized in a core compiler MPI. So the core modules basically provide modules for compilers like GCC, like Intel. And this is all you see. So initially, when users do module avail, they only see compilers. The idea is that you want to make sure that if people load modules together, that they are actually compatible. So they were installed with the same compiler, same MPI, and so on. So you don't get this in a flat scheme. So what happens here, if you load one of the GCC modules, it's like a new box of modules is opened for you. And if you then run avail, you suddenly see MPI modules as well. If you load one of the MPI modules, you see maybe libraries that sit on top of this, and also applications and so on. So people have to like pick a path in the modules, and then they have all the applications available to them. So module avail is very short. Initially, Lmod has a separate command, module spider, which allows you to look across the whole set of existing modules. So they're not available for loading straight away, but Lmod will tell you, okay, if you want to load FFTW, you'll first have to load a particular version of GCC and MPI, and then you can load FFTW. So it's a way of organizing things that basically forces people to only load compatible modules together. And it cleans up your module environment. You get less modules out of the box. Even when you have both of these loaded, you still get a lot less module avail because all the others are not shown. Module names are short. You can keep it software/version, that's it. So it has a lot of nice side effects. The only maybe downside of this is that your users have to be somewhat aware what this thing called a compiler and an MPI is, unless you load these things by default for them. So you can pick a path for them, load the GCC and an MPI for them by default, and then if they really want to, they can switch to something else. Okay, back to EasyBuild. One of the things we implemented, I think it's now 2 years ago, after we had an EasyBuild hackathon, so like a hands-on meeting at CSCS. At the very end of the meeting, somebody was complaining that EasyBuild is a black box for them, and they didn't like that. So it was doing its magic, and they felt they were losing control. They couldn't really tell what it was doing, at least not up front. How it was going to install the software. They wanted to check all the details. They had application experts that wanted to check how is it doing it. And they were a little bit annoyed about that. So on the way back home, I worked on what ended up being the extended dry run, or EB-X, which runs in a matter of seconds. So it doesn't actually do the installation procedure, but it shows you what it's going to do. So it specifies the full environment. It's going to run commands in which commands it's going to run, in which location, which source files it's going to pick up, what the module file will look like, and so on. So to give you an idea, this is what it will look like. So you just run EB with an easyconfig file like you would when actually installing it. You just add -x. It will start spitting out a whole bunch of text, which you can scroll through and inspect, and it will basically tell you, okay, I'm going to install this module, or pretend to install this module. I'm going to consider these download URLs. This is the tarball, and I found the tarball at this location, so that's what I'm going to use. During the build step for WRF, it says, okay, and this is how I'm going to run the compile script. So here you have to run compile actually 3 separate times. That's just the way Wharf works. Once with Wharf and once with a kind of test case which generate additional binaries. It doesn't actually run these, it just tells it it's going to run them. Here it also says, okay, once the installation is done, I expect these files to be there, so that's what I'm going to check, and so on. And then also it will show you what the module file would look like once it's generated. It's actually nothing of this is really happening, so it only spits out text, but it's a way for you to check on what EasyBuild is going to do without actually doing it. You can inspect the installation procedure even until the nasty details. I didn't show the environment, but it has like a bunch of export commands. It also tells you which modules it's going to load and so on. And this was exactly what the people at CSCS were looking for. So it opens up the black box that was EasyBuild back then. Another very cool thing, which I actually did over a weekend, just because I was bored, I guess, is integration with GitHub. So all the EasyBuild code, framework, EasyBlocks, EasyConfig files, they all have GitHub repositories. And if people want to contribute something back, they have to open a pull request on GitHub. Now, not everybody is familiar with this. If you're a sysadmin, you may not be familiar with Git, or maybe not with GitHub. So we found that people were willing to contribute back, but they were lacking the experience with Git, and we certainly didn't have the time to teach them Git. So if you're totally new to Git, it's kind of challenging to get to know it. So I wanted to fix this issue because it was a limiting factor. People were not contributing that back just because of the whole procedure they had to follow, which was annoying. And also it can be quite time consuming. There's a bunch of steps you have to follow. They're not very complicated if you know what you're doing. But yeah, if you're doing, let's say, 20 pull requests every week, you have to spend a bit of time on it. So what I ended up doing is I looked at a Python module to talk with Git, and talking to GitHub through the API to basically automate this whole process. And we ended up with this new PR, update PR command line options. To show you how this works, so this is basically the contribution process you do if you do it manually. So on your laptop, you would do check out the develop branch, create a new branch, add a set of EasyConfig files, double commit with a sensible commit message, push it out to your fork on GitHub, and then go to GitHub and click a couple of buttons to open a pull request. One of the things you have to keep in mention is we want your pull request to go to the develop branch, for example. So there's a couple of things you have to get right. You have to know Git a little bit, especially if you screw up somewhere halfway here, Git reset hard, and yeah, who knows what you end up with. So for some people, this was challenging. So with new PR, it basically, so this whole process becomes a single EB command. Just do EB new PR, you list the location of the EasyConfig files, and EasyBuild takes care of everything for you. It does all the Git magic in a temporary directory, which you will throw away afterwards, and it will go also onto GitHub and do the clicks for you. So just by talking to the GitHub API, it has a very powerful API. So for people that are not familiar with Git or GitHub, this is perfect. They're just talking to EasyBuild. You don't have to worry what's behind the scenes. If they have to update an existing pull request later, same story, update PR, works really well. So we started to get more contributions because we added the support. And even for experienced contributors, including myself, so I do this probably 10 times every day, because it was a single command, it became a lot easier for me as well and more time consuming. I was making less mistakes. My pull requests were cleaner, all of this stuff. This was really useful. And it goes beyond that as well, so we can also do it the other way around. We can pull in EasyConfig files from a pull request from GitHub, and then upload the test report back. So people can say, okay, there's a new contribution. I want to check if it works on my system. They do from PR with a number. They make sure everything gets reinstalled that's coming from the PR. It enables the dependency resolution. And when the installation is done, whether it failed or succeeded, it will upload the test report in the GitHub pull request with a link to a gist that has the details of your system, how long it took, which modules were loaded, all the magic is there. So if it works, fine, you get a confirmation that it worked for somebody else. If it failed, you get the log file is added to the test report as well, and you can dive in and help figure out what's wrong. Yeah?
So quick question, sorry. Does it work with EasyBuild? It's only...
Good question. For now, it's only EasyConfig files. But we're going to extend this to EasyBlocks as well. And what this thing also does, it does a couple of checks on the EasyConfig files, and it will tell you if something is wrong that you'll have to end up fixing anyway. You could do that for EasyBlocks as well, check for syntax errors, for example. We're also going to do it for Framework. And that's interesting because you'll be able to fix a bug in your EasyBuild installation, and then let EasyBuild figure out what changed and make a pull request for it. So you don't have to worry about creating a patch or a branch, or EasyBuild can figure it out itself. And it's a general concept. You could do this with other software as well. It's not specific to EasyBuild. So EasyBlocks and Framework, not yet, but we're planning that. Okay, and then the EasyBuild community, I consider this a feature of EasyBuild as well. There's a community that has emerged around it. It's very helpful, very welcoming. There's quite a bit of overlap between EasyBuild and Lmod as well, so you see the same names popping up on both mailing lists. We've had an IRC channel for a long time, so old style Slack, let's say. And we got some requests for a Slack channel, so we started this a couple of months ago. I was a little bit reluctant because I wanted to avoid that you have like two groups of people talking to each other, or talking inside the channel and not to each other. But we have a bot that interfaces between these two. So if you say something in IRC, it also shows up in Slack and the other way around. So if you're old style, use IRC. If you like the new hype, use Slack. The only downside is for Slack, you need an invitation. So you need to talk to somebody that's already there that can send you an invite. Community is very helpful, very welcoming to new people, and it's very active as well, reporting bugs, doing feature requests, sharing ideas, and also a lot of active code contributions. So to give you an idea of how big it is today, this is the mailing list, the number of subscribers over time. So when we started, this is basically the public release, so we started the mailing list back then, and today we have over 200 subscribers, and the growth is pretty scary. So this is just the number of people on there. This is the traffic we get. It's been rising steadily as well. This is this year. We're almost halfway, so we're certainly going to go above this. So quite a bit of volume, over 1,000 messages per year. So you better set up a filter and check it every now and then. This is a nice thing I did. So one of the difficult things is when you have an open source tool, who is using it? I mean, they don't tell you unless they have a problem. You will not know that they are actually using it. So what I did here, we've been tracking our EasyBuild documentation with Google Analytics, which can give you a map like this. So this is cities, basically, all across the world. And this is cities from where the EasyBuild documentation has been visited at least 10 times in the last year. So I'm kind of assuming if somebody visits it 10 times in a year and stays there for a while, they're using EasyBuild. I think that's a fair assumption. I don't know of any better way of doing something like this than Google Analytics on documentation. This was just cool to see, and you can see it's kind of European-centric. Certainly the blue thing here is probably Gent and the other Flemish sites combined. We have active contributors in Australia, some people in the US as well, Cuba, and so on. A guy in Singapore helping out with releases. So you see all of these things kind of pop up in this, so that's interesting. And then contributors, we get a lot of pull requests, certainly for EasyConfig files, so that's certainly a lot easier than doing code contributions. So to do EasyBlocks and Framework, you have to know enough Python to make some changes and make sure you're not doing anything totally stupid. For EasyConfig files, you can very easily change a version if there's a new release of a software and give back the EasyConfig file as a statement like, this worked for me with a new version, so please include it. So well over 100 contributors with easy config files and still growing pretty fast. Another aspect of the community is that we're trying to focus the efforts of the community a little bit on particular tool chains. So we have 2 community tool chains, and this is actually a result of the collaboration we have in Flanders. So during one of the discussions, we said, okay, most of the sites are using EasyBuild, but there's too much scattering of which Intel compiler versions and GCC versions people are using. So let's focus this. So we ended up with common tool chains, which is just an Intel tool chain and a FOSS. So FOSS is for the open source software, GCC, OpenMPI, OpenBLAS. And every 6 months, we define a new version of these tool chains, which is a combination of all the components in there. And then we say, okay, for the next 6 months, this is the tool chains we're going to use to install software. So we're keeping up with what's new, and we're working together to help out each other. That's kind of the idea. So in the next couple of weeks, we'll be doing the 2017B, which is probably, I don't know if there's a more recent GCC version, but there is an OpenMPI 2.1 something. So all of these will be bumped. And then what we do, we also check all the installations that we did before to make sure there's, the compiler is not suddenly very, very picky, or there's some tests as well to make sure that MPI is pretty stable and so on. A lot of other stuff that I didn't cover, so take a look at the documentation. I have to say the documentation is definitely not complete. It can do stuff that's not mentioned there, but we hope to fix that in the documentation. As I already mentioned, users can manage their own software stack on top of the modules we provide centrally. So that's certainly a good aspect as well. There's this thing called hidden, you can hide modules from view in module avail. So Robert was mentioning this. So EasyBuild knows how to do that as well. It supports RPath. So right now, it mostly does LD library paths. So it injects LD library path statements in the module files. But after talking to Todd, we got convinced that RPath is actually a better option for a whole lot of reasons, which is supported as well. Now, it's still experimental, so we're saying be a little bit careful if you use this. But Pablo has been using it for weeks now. There's a guy in Sarsara in the Netherlands has been using RPath as well, and it seems to be very stable, so we're going to declare it as being stable pretty soon. You can do partial installations. You can only regenerate the module file rather than doing the whole installation again. You can install additional Python packages without starting from scratch. You can parallelize installations. So you can, if you want to install Wharf and it needs netcdf and HDF5 that's not there yet, you can just submit all of these installations to the cluster as a job, and it will get the order between the jobs correct, so you can actually parallelize things. You're sitting on top of a cluster anyway, so why not do that? It can create RPMs for you if you want to maybe do the installation in one place and then roll out RPMs somewhere else. We leverage the FPM tool for this, so the fucking package manager, which can not only do RPMs, but also Debian files and a whole bunch of other things. And we have good support for Cray. Future work, a lot of ideas, not enough time to actually do them. So the RPath support is pretty much there. You just have to double check a couple of things before we declare it stable. After, I don't want to say complaints from Todd, but after Todd pitching us checksums, we figured we really have to do a better job of checking the sources we download. So we're looking into this on how we can do this easily for all the easy configs we have, which is a bit of a job. We try to have a consistent style, not only in the Python code, but also in the easy config files. So have things in the same order. So if you check a new easy config file, it's easy to check which version, which toolchain. So you basically get the same thing over and over again. We want to automate that process because it's a bit labor intensive to do this for contributions. We want to add support for checking, so letting EasyBuild check whether there are software updates available, so whether there's a new release of something, rather than have to go to the website manually and this is OpenAPI 2.1.2 is the latest one. Let's install that. No, EasyBuild can actually do that for you by just querying the website or page scraping or who knows what. We want to be a little bit more flexible in terms of dependency versions, so now everything is fixed. And Todd will show you how Spec is doing it, which is like the other extreme. It's very, very flexible. I think we want something somewhere in between, at least in EasyBuild. Setup tools is a pain in the ass. We want to get rid of it. So EasyBuild requires it today. I want to get rid of this because the maintainer is yeah, I'm going to stop talking because it's recorded. But I think you get the idea. It's annoying to rely on setup tools for different reasons. Python 3 support, so EasyBuild doesn't run on Python 3 yet. We're not too worried about that yet because all of the big Linux distributions are still using Python 2 by default. And even if they're not, Python 2 is not going to go away in the next 5 years or so. But at some point, we'll have to start worrying about this. It's not a whole lot of work, but it's a bit tedious to do this. And we've been working for quite a long time now about a new syntax for easyconfig files. So now we're doing Python syntax, which has its downsides. We have something that works in YAML, but it's not really complete yet. And one of the things we want to do is what we refer to as fat easyconfig. So rather than having one easyconfig per version and toolchain, we want to have a single easyconfig file for the one particular software package that just says, okay, all of these versions, all of these toolchains, all of these combinations are tested, are vetted, and you can combine those. So better collapse things a little bit and make it easier for us to maintain easyconfig files. A bunch of papers, so the links are included. There's a paper on the Cray Support, a paper on combining EasyBuild and Lmod and using a hierarchy. And then this is like a side report from the guys in Jülich, how they are using EasyBuild on their Eureka system, so a big x86 cluster. And to roll into the Spec talk, I have 10 more minutes, so I can steal some of Todd's thunder here. Let me try that. So Todd, if there are any lies on here, tell me. I try to be objective. And it's not like it's a positive story for EasyBuild and a negative one for Spec. That's not the case. So Spec already supports Python 3. EasyBuild doesn't yet. EasyBuild is GPL v2. Spec is a little bit more permissive. It's LGPL. So if you're worried about licensing, this may be important to you. In my view, and this is a bit of a personal view, but I think Todd mostly agrees on that, is that EasyBuild is targeted to support teams, so people that have to install software for users, while Spec is more oriented to developers of software that have to juggle a lot of dependencies and... Okay, but you can explain why in your talk.
Okay, wait.
Okay, yeah, sure.
Yeah, we have sites running Spec in production, and it was targeted at Livermore's users.
I'm not saying that's not the case. I'm just saying that the features it has, it's more targeted towards developers of software. All the flexibility it gives you for dependencies, I'm not sure you want that too much. But you can show that in you have 2.5 hours, I have 1. So. We've had stable releases for EasyBuild since 2012. So stable means something that you could install back then, like a particular version of a software or a particular toolchain. You can still do it now in the exact same way. It'll still work, even though it's 5 years later. At least if your OS is not too new or too old. Spec is still alpha software. Is that right? Or is it beta? It's not 1.0, yeah. So that's basically what I'm saying. You're close to this, but it's not fully stable yet. But people are using it in production. It's not like it's totally crap, but...
I wasn't looking for that, okay. So
in terms of supported software packages, it's close. So if you do the count, let's say right, so Spec here has 1,500 software packages, more or less. I checked this yesterday in your develop branch, it should be close. This includes Python packages, R libraries, all this stuff. In EasyBuild, we kind of count it separately because extensions are included in a particular installation here. If you do a fair comparison, it's about 2,000, 1.5K, so it's pretty much the same. This has been growing really fast in Spec, so that has been impressive. In EasyBuild, all the versions are fixed. Spec is very flexible, and Todd will show all about that. EasyBuild requires a modules tool, so it really relies on that. It can't work without a modules tool, while Spec has other ways of doing things to prepare your environment for the installations. In both EasyBuild and Spec, you have a core library in Python, and then in EasyBuild, you have EasyBlocks and EasyConfigs, and you have to combine those to install the software package. And Spec has packages, so everything is in Python. You don't have separate build specifications, which you do have in EasyBuild. EasyBuild can now do both LD library path and RPath. I think Spec can only do RPath today because you're just not interested in LD library path. Is that right? Yeah. And EasyBuild support, yeah, Linux HPC, so Red Hat, SUSE, Debian, that all works. Cray has very good support for Cray as well. And then Spec is more broader. It also works on macOS, Cray, Blue Gene. Is that right, Todd? Yeah. So it has a little bit of more. The claim we're making here is we're basically not interested in macOS. So if you are, then maybe Spec is a better fit for you. Both of them are backed by an active and supportive community that's, I think, pretty much the same size. A couple of hundred sites being used. Yeah, I think we're pretty much on par. And there's one very important thing. EasyBuild has stickers and Spec doesn't yet. So if you want a sticker, you can get one. Yeah. Yeah, anyone can get stickers. Okay, yeah, that was it. Hope I have time for a couple of questions.
Thank you.
Hi. I have two silly questions.
Okay.
The first one is there an easy way to update EasyBuild?
Yes. Okay, that slide wasn't there. Yes, you can update EasyBuild with EasyBuild.
Okay. And
it has an option to.
Okay. And the second one is if there is also an easy way to update just the config files and not the whole package. Imagine that you have a repository of config files and you can do a EB update or something like that and grab every config file that you have.
Okay, yeah. No, in the sense that we just package the easy config files together with EasyBuild. So if you install the new EasyBuild release, you'll get support for, or you'll get a whole new bunch of new easy config files.
Yeah, exactly.
We don't have a separate command for that, so to do like in between. But what you can do is you can just clone the easy config repository and do a git update there, or git pull, and then tell EasyBuild to use these easy config files, and usually that's okay.
Okay.
So like in between releases, you can pull stuff. Or just pull it from pull request from PR. You can do that too.
Okay, thank you.
I think you know the question.
Maybe.
In the management of software is indeed difficult, but I see more like taking all the life cycle of the software. So installing is not just about installing, but it's also about removing. So do you plan to create an easy removing or something, easy remove or something that can take care of the dependencies and remove the dependencies that are not used by other packages? Because when you really, let's say a software is buggy and you want to really remove it, you have to go manually, and that can be really painful, I would say.
We're not supporting that yet. It's an idea we have and not time to actually implement it. The thing we're missing is to do reverse dependency tracking. If you install something, you have to like add a tick to the dependencies to make sure that they are still being used by something. That's basically what we're missing. So we can have an EB remove option, but then it needs to know which dependencies are being used. I guess it could scan just all the modules or something, but yeah, not today, but it's planned.
Yeah, you should talk with Gent, because we have done some kind of reverse dependency.
Okay, that's interesting. Yeah. Okay. Any more questions?
More things?
It's only a small detail, but I'm not developer of Wharf, but I feel a little bit concerned that you've been quite critical with the process of installation of Wharf.
Okay.
And I would assume after working with a few Earth system models, it has a procedure, and if they try to do something, it's not perfect, but it's one of, I don't know to say if it's the best, but it's something that you can understand, and it's, so you cannot blame that the NetCDF it's split because it's not their fault.
No, it's not. It's not their fault, sure. But I'm just saying it's not as easy as configure, make, install.
Completely, but go to other models and it will be.
Wharf is the easy one. I
yes.
know. The others are a lot worse. I know. But I tried talking to the people behind Wharf at the recent supercomputing, and they just didn't understand my problem. They didn't see that it was too hard. I mean, they're used to it. They're doing it all the time. But if you're doing 1,000 applications and Wharf is one of them, I mean, people spend days installing Wharf. OpenFOAM, the CDF thing, is another good example. People spend a week getting it to work. So
We know that.
Yeah.
That's why we are doing
You don't
this
because you're
effort.
experienced, but
No, but we are this effort of the usability of installing the system
it's an
models
ongoing,
because we know, and there are other models that are in all other crazy solutions as
I know.
FCM and all these things that it's even worse. So.
Yeah. But was the picture accurate, or was I telling lies?
No, it was. When you say that there are test cases, you say that you need 3 steps at the end.
Yeah.
It's not really test cases. It's cases in real because it's not the same for each. When you are doing EM real or the other one that you were doing at the end, it's not test cases. You are compiling the model because you need it to run in a way.
Yeah, my problem there is like you do compile WRF and you get the WRF binary, and you need ideal and real.exe as well.
It depends on how you run your model.
Yeah, but we just want an installation that works for anyone, right? We want everything to be there.
You can be, and for example, I realized that for this, if you want to do it in a scientific way, that you need to change the output, your procedure with EasyBuild is really too difficult to handle this because you need to enter in a few files to change it. So
Then maybe would it work with a patch file that you can just apply a patch file?
Yes, but do you tell the scientist to create a patch file?
No, we tell them ask us. We will create the patch file, redo in separate installation, and do module load. We don't expect domain scientists to be able to install software. I mean, a lot of people don't even know what a compiler is, so let alone dealing with compiler errors. I mean, for the people developing the software, they know what they are doing. But we've worked with industry that uses WRF. Now, for them, it's way too difficult. They can never do it without EasyBuild. They cannot do it. Stickers, yeah. Get some stickers.
So if we cut that thing a little bit, the record, I mean, maybe we can be more open. But so I have to say, WRF, it's quite a complicated one in terms of dependencies and so on. But there are other softwares that they actually need to develop a framework to build the software. So it's the case of a unified model, or maybe other very popular climate modeling software packages that, so it's quite a...
If you're dealing with a lot of dependencies, it gets very tricky. I'm not saying it's easy. There's no easy way to do this. But inventing your own tool just to be able to install one application is...
It's not just getting that thing built. It's getting built and getting performance out of it. Because usually it's not just a matter of being able to run that thing. So to run it properly, it's what it's time consuming. And tuning, it's part of what is missing in WRF as well.
Just a comment, maybe we are not doing it properly, because instead of telling scientists how should they build their software, what we do is we adapt to their way of building the software. So they continue doing it wrong.
Yeah, but try doing it the other way around. They will not listen to you. Either they won't listen, or they'll say, but it works for us. So why should we change? They don't see the point very often. And WRF is not even, I mean, there's bioinformatics software, Chime. Sometimes I include a dependency graph of Chime. It doesn't even fit on a slide, and it's huge. You need Haskell, Python, Perl, God knows what. You need everything, and yeah. What they do is they give you a container and say, just use the container.
And the other thing that we were discussing the other day is that currently you have a set of easyconfig files, but most of them, I don't know if all, but they have not been checked, and nobody has checked the performance or how good these easy blocks are that build this software. So
need a kind of scoring system or a labeling system for
like a rating system, so that you can be sure that somebody has verified this easy block, and you are getting a performant installation of the code.
Yeah, it's a very good idea. We should look into that. It's not easy. Yep. Make sure you don't steal too much time from Todd.
Yeah, just a very simple question. As I've been using EasyBuild for quite a while, I didn't check the manual lately. So, and as I look for software, I just grab the output of -s, okay? Or there's another way? There's another way to look for...
Well, the website has all the software packages
No,
we
but what
support
I
in
want
the
to-
latest
yeah, but
release.
I'm on the command line. I just want to
And
look
it has
for
it-
OpenFOAM, for example.
Yeah, then searching, EB-search
Then
is your best option.
if you go to this easyconfig monolithical files without the versioning in the name,
Yeah.
you have to do some tool. I'm just telling you from the user point of view, because we could not grep then the easy blocks
It's too,
and the chains.
too hard to figure out what is provided in the easyconfig files? What, it's too manual, or?
To check the versions, for example, if I want to know if I don't know, whatever software is compiled with a GCC 6, for example, okay, or with certain Open Blast library.
Yeah.
Now I can grep.
Okay, so we need a...
But if you have everything in one block, I cannot grep the output of the list of blocks. I will have to go there, look for it.
No, we should discuss this afterwards. Yeah.
So one more question, and we will wait for the roundtable around
Sure.
package management.
Yeah, Todd and I can have a fight.
So I have a question about how you're dealing with the modules. You mentioned you don't expect the users to know what a compiler is, and I completely understand because my users doesn't know what it is. But you're also mentioning that you're using hierarchical modules.
Well, no, and Gent we're not.
Ah,
EasyBuild supports it, but it's up to you, up to the site whether you want to use it or not. But that, yeah, if you're using hierarchical modules, we're kind of forcing that people at least have a notion of what a compiler is or why they have to pick a compiler first.
yeah,
Because they don't care about compilers. They want to load Gromax, right, or whatever.
exactly.
Yeah. So that's the downside of a hierarchy. I've been thinking about a way of turning it upside down and have the applications visible by default. And then once you load an application, it basically collapses the module tree into only what's compatible with what you loaded. It's not easy to do that. There's problems with that. But that would be the ideal situation. Only applications, and then once you load something, it collapses and you can only load stuff that's compatible with what you load. Yeah. Maybe someday.
Okay, we have changed a little bit the plans. We're going to have the coffee break in 10 minutes, so we can continue the conversations around this bit. We could anticipate a little bit the roundtable, but you haven't had any opportunity to explain what is a Spec. So I feel that it's not too fair, but so it's we can talk about that thing later. So it's
We can do a
we have a lot
roundtable
of time.
over
We
beers.
have plenty of time. Okay.
We can do a roundtable over beer.
Now, okay. So one question for EasyBuild, not for the roundtable. I have seen that EasyBuild have a support for RPMs, so you can create an RPM after compiling the whole thing.
Yeah.
So do you have any plans in mind to, for example, accommodate similar kind of requirement for building a singularity container?
Yeah, I was expecting
Because
that
it's just a minor step between RPM and to generate a singularity container.
It's a pretty small step, and the packaging support we have is kind of targeted towards other options like Singularity. I was discussing this with Pablo before. It's actually better to add support in EasyBuild to generate Docker containers, because then you can do anything. Singularity can use Docker containers, Shifter can use Docker containers, can use Docker containers straight away. So maybe Singularity isn't a good target, but Docker would be. And it's not integrated in EasyBuild. You can just run EasyBuild in a Docker file and install the software in the container with EasyBuild.
Okay, well, but this means that you need the whole lot of building tools inside the container.
Yeah.
You know, to build everything.
So, yeah, it's not perfect.
I know that it's full.
I think you need a cleanup phase or something as well. You can throw away the stuff you don't need anymore just to run what you care about. But yeah.
Yeah, it's what I was thinking, actually. So
Use what?
Send BMFS.
Okay, yeah.
Wait.
Let's keep this for the roundtable, Jordi. Todd is getting annoyed.
Yes. I also thought about this CBMFS, and it sounds cool, but I want containers for portability. And if I need CBMFS, I need to ask the admin in the new cluster to deploy CBMFS for me. So it doesn't solve the portability issues which is one of the nice things of containers.
Well, Unity registry as well, so it's not going to be fixed straight away. So sorry, it's going to to move to a container topic discussion, which is not related with the HPC, but so it's a need.
Well, it kind of is. It makes it very easy for people to run their stuff anywhere. So I think it is relevant.
Yeah, in my opinion, it's the way to go. Especially with all the bio crap, which it's impossible to, or like this scheme you said, you know, if the developers provide a container, how many time I will save in my life installing this?
I think they have a container. Chime has a container.
Sorry?
I think Chime has a container.
Now, yes. But
now,
when I built all the recipes for EasyBuild, it was not the case.
Yeah.
Also, they provide now Conda things, but yeah, so I think it's the way to go. And even if you have a little bit penalty on performance, and if you have to spend some extra hard drive is much cheaper than admin time.
And then a lot of time they're asking for software just to give it a quick try and then never use it again. And then if you spend half a day getting the thing to work, and they say, no, I actually want this other tool. And then, no, this one. Oh, I want to do a conference, I want that one.
So thank you so much.
Thank you.